Let's see how to calculate this irrational expression. So square root of 39 can be split as square root of 3 times 13, right? And then square root 12 can be split as square root of 3 times 4. So let's simplify first. So that means the numerator, I can factor out square root of 3. Then square root of 39 now becomes square root of 13. Then plus 1, right? Because 1 times square root of 3 is the square root of 3. The denominator, I can also write square root 12 as square root of 3 multiplied by square root of 4. Then now I have square root of 3 divided by square root of 3, that becomes 1. Of course, this is raised by 6. So now this expression I can simplify to be square root of 13 plus 1 divided by square root of 4 is 2. Then raised by 6. So raise this one to 6 power, that's a lot of work, right? Especially to deal with square root of 13. So what can we do? We can do this, this. So let's use a variable. Let's see, let a k to substitute square root of 13 plus 1 divided by 2. Then we can rewrite this equation as a 2k minus 1 equals to square root of 13. Now I square both sides. Square both sides. Square root of 13 square just become 13, right? So 2k minus 1 square, perfect square. I got 4k square minus 4k plus 1 equals to 13. Now subtract 1 from both sides. So 4k squared minus 4k equals to 12. Then I can divide this whole thing by 4. So write it as k squared minus k equals to 3. Right? 12 divided by 4 is 3. So now I can rewrite this equation as k squared equals to k plus 3. Right? Move this negative k to the other side, 3 plus k or k plus 3. So now this is beautiful, right? This allows us to reduce the power of k. Now let's come back here. So k is this expression, right? So we have k squared now. Let's calculate k to the 4th power, which means this to the 4th power. So that's k squared, then squared, right? And k squared can be written as k plus 3. So that's k plus 3 squared. Then that's k squared plus 6k plus 9. Right, perfect square. The middle term is k times 3 times 2, 6k. Now we use this relation, k squared, to substitute this. So that's k plus 3 plus 6k plus 9. So we get k plus 6k, 7k. 3 plus 9, 12. So that's k to the 4th power. Now we have k squared, k to the 4th power, can multiply. Okay, so now we have this. So let's do k to the 6th power, right? Means this to the 6th power. So I have k plus 3, which is k to the 4th power times k squared. The k squared is k plus 3. K to the 4th power is 7k plus 12. Then multiply k with 7k. We get 7k squared. Multiply 3 with 12. We get 36. Then 3 times 7k 21k. K times 12, 12k. Combine like terms, we get 7k squared plus 21k plus 12k, 33k. Then plus 36. Again, let's substitute k squared with k plus 3. So that's 7 times k plus 3 plus 33k plus 36. So we get 7k plus 21 plus 33k plus 36. 7k plus 33k, that's 40k. 21 plus 36, that's 57. Right, so now we can substitute k. Well, let's remind us that's k to the 6th power. Well, k to the 6th power, just k is the square root of 13 plus 1 divided by 2. I should rewrite that. Square root 13 plus 1 divided by 2 raised by 6 equals to 40 times k square root of 13 plus 1 divided by 2, then plus 57. So we just have to simplify this a little bit. Right? 40 divided by 2, that's 20. Then we have 20 times radical 13 plus 1 times 20 is 20. 20 plus 57, 77. So the answer is 20 times square root of 13 plus 77. Right? So that's for this question. So the key step is the reducing power part is this one. K squared equals to k plus 3. So that's why we use the substitution method. Right? So we can calculate, we can square root 13. Then we don't have to deal with the irrational numbers anymore. We don't have to deal with radicals anymore. So that's the key point of this question.